Hello, everyone. My name is Asger Wendt Karl. As Ian said, I'm from Sweco, Denmark, and I'm here to tell you a little bit about how we try to preserve the complexity of EPDs in building LCA context, or more likely, how we struggle to preserve this complexity. We've heard a bit about LCA so far today. I will try to dive a bit more into LCA as it pertains to buildings and how we calculate this in a Danish context, both in terms of how it is done in practice, what the legislation says, and sort of what the journey has been so far, and how this interacts with EPDs. We've heard a little bit about it today already, but the stages of a life cycle can go anywhere from cradle to grave, cradle to gate, cradle to cradle. When we are doing an LCA at the building level, we start at the production of materials, so this will be where you play a part as manufacturers and the data that you can supply. Transportation, construction, use and maintenance, and at the end of life. We try to quantify all of these stages in a building LCA context to try to understand the building better, using all of the data to assess our environmental performance, the burdens we incur. But in terms of legislation, it is not quite that interesting, because really we are just looking for one number, and that is CO2 equivalents per square meter per year. This is essentially what it all boils down to. This is what we want to calculate. So while an LCA can be a great many things and have a lot of complexities and nuances, there are much more interesting things to look into than simply CO2. I mean, we heard CO2 tunnel vision before. This is very much a case of that. But it is also a case of having to start somewhere and then try to improve as you go. What we have now in Denmark is a requirement to be within a certain limit value of how much CO2 you emit over the course of your building. And if you are not within these limit values, you do not get a building permission. So what you do in this stage at the calculation and what the EPDs supply in can be very crucial. And the EPDs play a crucial part in the building LCA. Maybe not yet for HVAC or HVAC-R products, because it is it's a journey. So you start somewhere. You start with some other building components. Typically, at least in Denmark, there has been a lot of focus on concrete, steel, windows, the whole facade. But it is evolving, and more parts of the building are playing a more crucial part. When we build the building LCA, we have these 3 stages of data available to us. So we have generic data. This is found in some European databases. It's not very precise. You cannot differentiate between one product that is made in Italy or one that is made in Sweden. So it's very generic. It's very rudimentary for the very first calculations that you make. One step better is industry data. So this could be industry EPDs, where a industry organization goes together, maps out all the manufacturers, the whole industry, and then to produce sort of an average data set that is a stage better than generic, but still represents the country that you are in. And then the tip of the pyramid is then the specific EPDs. So when a manufacturer has their own EPD for their own products, their own product lines, that you can then base your building LCA on. So this is where you are as close to reality as you can get. Of course, there's still some nuances that you lose. But this is also showing what we have the most of. So we have a lot of generic data. We have some industry data. We are lacking on specific EPDs, at least when we're talking about HVAC. I apologize for the AI picture. I needed an image showing sort of the inside of an air handling unit, sort of just to briefly talk a bit more about the complexities, and I couldn't find one that was not proprietary of someone in this room. So when you make an EPD, you look at the whole, you map out your whole production, everything that is occurring at your production sites, all your sourcing of materials, how you produce it, and then how it is used. This can be simple for some products and very complex for others. So for concrete, for instance, you simply need to know which materials you have, the ratio you mix them in, and then once they're installed in the building, you don't have anything more to do with it. With an HVAC system, you have some other difficulties, because in your upstream, you might have components that are pre-made by someone else. Maybe they don't have an EPD, and they don't wish to share this data with you. Then you have a very difficult time making your own EPDs. In the same way, the downstream can be very difficult, because the way that your products are used in the building are a key aspect in the performance of your EPD. And you don't know this ahead of time. When you make an EPD today, you look at what did we produce last year. but the building that this component goes into is built next year. So there is a disconnect there between what you supply and then what is actually needed. In Denmark right now, the status quo is we have now 3 industry EPDs, where the whole industry of Denmark came together to like 80% of the supplied products. We have one for circular ducts, one for rectangular ducts, and then we have one EPD for non-residential ventilation units. And in this one, we have 2 data sets, a big one and a small one. So that's what we have. So when we make our building LCAs, we try to calculate everything, the whole life cycle. We try to get to this number to show how much CO2 do we emit. Are we within the limit value? We have this data set to scale from. And we can't separate between your product or yours. We have this one data set. So that's the problem right now. We cannot really get closer to the truth until we have more product-specific EPDs. And when you make your building LCA, at least for my colleagues and me, the one dimensioning factor we have is how much air do you need. So cubic meters per hour, that's it. So we don't really dive further into it because we don't have the data to do so. How do we then get from generic to specific? So it's one thing for data. I mentioned it now. We want to go from generic to industry average to specific data, from something that is inaccurate to something that is more highly accurate, and something where we can compete with different products, where we can bring in our performance and all the stages of our production to then perform better or at least more suitable for the building case. But in the same way, we have an issue in procedures. Now we are still very new in the whole process in Denmark with building LCAs, so you have to go very quickly from very generic procedures, some inaccuracies, quick calculations, to rules of thumb that we don't really have, and then end up at some specific calculations. This is both in terms of energy design and also the building LCA. But it is a journey that is difficult to do more quickly than we do it now. It takes a lot of years to build up the expertise, to have the data, and to set these limit values. An example we know from the concrete industry, which of course have faced many of the same issues, but they have been forced to adapt more early. You start out with generic data, then you make industry EPDs. They did that. They then made an EPD generator, so all of the participating manufacturers in the concrete industry could make their own EPDs, which was the next step. And now what they're also capable of is project-level EPDs. So this is when a concrete manufacturer can say, this specific concrete that ends up in that windmill, it looks like this. Or this specific concrete we're mixing for this high-rise has this exact performance. And then you really utilize it in the design of your building, because you can tell them, can you improve upon this? Or can this become better? Or do you have anything new for this? So here you can really input your EPD data to actually design your building with. And this then follows the requirements that are put forth by the building commissioners or the clients, because they then know, oh, we can move something here, or we can improve, or we have more data. A typical building LCA process, at least when we are looking at it with the HVAC glasses, is very much in connection with the energy design team. Because on one hand, as I said, in terms of the LCA data, we are looking at cubic meters per hour, but of course the energy demand is also a key factor. But as LCA consultants, we don't do those calculations. We have colleagues that do this, and they are much more in dialogue with the ventilation unit manufacturers, because they need to know the exact efficiency numbers and the exact specifications of the products that they use. But you go from early stage to qualified calculations. At some point, you reach a final design, and typically, this is where you have your final LCA. You will make an early one, and you will have a final one. Depending on how ambitious your client is, how much of a prestige product we're looking at, there might be a lot of different iterations where you have a loop between your final design and then qualified calculations. But sometimes your final LCA, it does not really match what is being built. And we don't have the measured values. This is something you do for the energy design when you're making your regulatory reports. You also got to look at what is being calculated is also what's built. But this step is missing with LCA, so you lose some of this accuracy. Now, as I mentioned before, in terms of losing accuracy, the big green dot in the middle, of course, this is when you have the tunnel vision, cubic meters per air, and how much energy do we need. But for those of you in this room that are working with EPDs already, you know there's a lot of different steps required to define your product. The frame, the casing, the motors, the software, everything in between. And as it is right now, we don't differentiate between that. So you might be much better in terms of software or the motors, or you make your own sensors, or you produce your own fans, but it has no effect as of right now in the building-LCA world. So which comes first, the data or asking for data? It's a bit of a chicken and egg problem, because I know some of you have probably been asked to supply data that you don't have, or you have supplied data that nobody asked for. So which comes first? It's not easy to answer. In Denmark, we had energy design as a design factor for a long time, from 2005, 10, 15, 20. We go from voluntary classes to it being mandatory for everyone, and then this then becomes current common practice for everyone. In the same vein, for climate change design, you looked to the energy design to say, okay, can we learn something from this? So you start out with a voluntary class, which then over a number of years becomes mandatory, and then the next step is sharpening the requirements. And this is where we are right now. We have new limit values as of this year, potentially 2027 new limit values, but we don't know. And then further out in the future, it's hard to say. But in terms of the requirements, it is still very much a new world. So how do we then go from all that we want to do and all the stages I've talked about today? Well, there's something missing. We are needing some kind of calculation tool where we can have energy design, building level LCAs and EPDs working in tandem in one unified platform, so that any choices you make in your energy design informs the building LCA and maybe utilizes the EPDs more actively, instead of it being a very static, iterative process where you have your energy design, this is then done, completed, shipped to the building LCA consultants, and then they calculate based on those numbers. But if they change, the whole machinery sometimes breaks down, more or less. So this is what we're looking into. This is the current problem, I would say, in this aspect of building LCA. And I just hit 0. So thank you, everyone. Thank you for your time, and thank you for being here.